Hello, everybody, and welcome to the course. A reminder, as I work through videos like this, I expect you to have this document in front of you, either physically or electronically, and fill it in as we go. I'm not going to give you time necessarily to write everything down, or you can just listen to what I have to say, go from there. But I am going to act as if you have this in front of you. So overall, we've got an introductory statistics course, and we've got a couple of major ideas in here, the major sort of branches of the course. One of them is descriptive statistics, like I'm saying here, talking about here, where we use plots and numerical summaries to describe a data set. And quite a bit of this is very straightforward. Quite a bit of this is things that you would have seen before, such as the histogram that's there and that kind of idea. So it's fairly straightforward. A notion of a mean and a median and a histogram thing, pie chart perhaps, and you're going to have seen a lot of these things before, but maybe we'll learn a few things at a little bit different depth, and things that we need for later on when we discuss the other major branch, which is statistical inference. And statistical inference is the big part of the course, I think. Helps us answer questions, answer research questions, helps us try to get to the reality of situations. And in our statistical inference scenarios, we're going to need some descriptive statistics too to do that. The main thing is that statistical inference branch, which is a little bit trickier than the descriptive statistics part. So part of the course, and we'll start off, we'll do this fairly early on, is do some things like a histogram. So we have a histogram and box plot of final grades from a statistics course. Final grade here, quantitative variable that's been split up into these different classes, and then we count the number of observations in each class, plot it out, gives us a distribution or a visual of the distribution of our sample data, and we can take various things from this away. So I'm sure we've all seen histograms before. We'll talk about them a little more as well a little bit later on. Then we have this box plot. Now, some of you will have seen box plots before, but not all. I know that. And overall, I need to introduce them now. It's problematic because I need to introduce them now because I want to show a few things using box plots. But to understand box plots for real, we're going to have to do some descriptive statistics first. So, what to do first. So how I approach it is I'm going to I want you at this point to just have the basic idea of box plots, just the basic idea. If you want to know the full details, I have a short video on it. You can find the full details now if you want, but we are going to be using them to compare groups. We'll have box plots for a few different groups together, and we'll look at them and compare the distribution of a variable between the groups. Not so useful in a spot like this with just one group or for this one class, but useful more for comparing things. Box plot here has a line at the median. So that median is the middle value in an ordered list of the observations, right? Down here at the bottom of the box is what we call the 25th percentile. So 25% of the observations are here or lower. Up here is the 75th percentile, so 75% of the observations are here or lower. And if there's no things plotted in individually up here, so we just have that line, that's the maximum, which is right around 100, right? And if there are little things individually here through dots or lines, it depends on the plotting software, then these are what we call like extreme values or outliers that are plotted in individually, just to give us an idea of that. Now, we're going to talk about this in more detail a little later on. I want you to have the notion that a box plot here, the vertical box plot, has the variable here and gives us an idea of the distribution. So just a different way of plotting things and useful for comparing groups. Okay, so we'll have histograms, box plots, various other things that we can look at in terms of the plots, and then mean, median, standard deviation, for a measure of the variability, things like this. And that's all part of descriptive statistics. Pretty straightforward, I think. In inferential statistics, this is the big thing, fundamental here. We're trying to make statements about populations based on data from samples. So the problematic bit is this population is usually or often very large and essentially impossible to look at all members of the population. So I might want to say something about 40-year-old Canadian males. No, I'm not 40, but those days are long behind me. But this is just saying, if we wanted to say something about 40-year-old Canadian males, well, that's going to be impossible to look at all 40-year-old Canadian males. From a practical perspective, it's impossible to look at everything. So we might want to say something about that group, about that population, but it's problematic that we're not going to be able to take measurements on that entire population. But what we might be able to do is get a sample from that group. We might be able to get 100 40-year-old Canadian males, and try and use information from the sample to say something about the population. And that type of thing is a statistical inference scenario. And it's problematic. You can imagine it's problematic. All sorts of questions arise. How did we get this sample from the population? How can we generalize now from that sample to that population? That's going to be problematic. Yeah, it is. So more details on that as we go. But that's what statistical inference is all about. Trying to extrapolate from a sample to some typically larger and typically very large population. And it is fraught with difficulties and problems. But that's what working through that will help us try and answer some questions. And overall, really, I mean this, try to get to the underlying reality. That's our goal. Try to get information about the underlying reality. And overall in all of this, our statistical inference techniques and the things that we look at and the statistical methods, most important is exploring and investigating possible relationships between variables. That's the interesting bit to us. You know, those final exam scores up there, plot this. I mean, okay, there's information, maybe some points of interest, but not nearly as much as when we're comparing and investigating, comparing groups or just overall investigating relationships and trying to see, explore various things related to that. So for example, let's look at a couple of examples and have this notion that do police officers or traffic police officers in Cairo tend to have higher lead levels in their blood than officers from the suburbs. And we have this based on this a study of 126 Cairo traffic officers. So that's a sample. There's more than that. And 50 officers from the suburbs. They have their lead concentration measured. And we have this notion, these two box plots. So again, we don't really need to know the specifics here. Get the big picture idea that it looks like visually the Cairo traffic officers tend to have higher lead concentrations in their blood. So it looks like, I say visually, that there's a difference between the groups here in that. But what statistical inference does is it tries to formalize this and says, okay, well, I mean, you're looking at that, and you're saying that, but maybe somebody else looks at that and goes, I don't really think there's that much of a difference, right? So statistical inference formalizes this, and we look at this and we say, how much evidence do we have that there's a real difference between those two groups? Like, does something like this give us a lot of evidence that there's a real difference? Or are we likely to see something like this just due to natural variability? And statistical inference gets at that. And there's a lot of trickiness to it. And we have to be very precise in how we go about things and say things. And it will involve certain assumptions. And we'll never know with certainty the underlying reality. But statistical inference is trying to get at that underlying reality. So we'd look at this, and let's say if we just, for the sake of argument, just looked at the medians, this Cairo traffic median is seemingly a fair bit higher than that of those in the suburbs. And I would look at that and say, with my expertise in this, in the sample sizes and all of that, I think that would be hard to see something like that just due to chance if in reality there wasn't something going on. So statistical inference, what that does, sort of big picture wise, would say, hey, let's pretend for a moment. Let's pretend for a moment there's no real difference between these two groups. Like in reality, the Cairo officers and the suburbs, let's pretend that they have same distribution of blood lead level. What are the chances of seeing something like this? And we'll go through and we'll analyze this. And you might say, how the heck would we be able to do that? Well, we'll need certain assumptions. And then when we make certain assumptions, if they're reasonable, we can go ahead and try and answer that through things like a two-sample t-test. It's one of the most common things in the world of statistics and science to investigate, a two-sample t-test. And that will enable us to say, hey, how much evidence do we have of that there's a real difference here? And a little more concretely, we say, let's pretend there's no real difference for a moment. What are the chances of seeing something like this in our samples? And that's what statistical inference gets at. And the reality is, when we learn later on how to do it, if we crunch the numbers, we'd see there's very little chance of seeing something like this if in reality there's no real difference between the two groups. So statistical inference is addressing things like that. And overall, like I'm getting at here, what I'm talking about there is this second part, testing if the observed difference indicates strong evidence of a true difference between the groups, not just in the samples, but beyond that. And that's what hypothesis testing is all about in statistical inference. And there's another part of statistical inference which involves estimating things like this. So estimating the real difference in mean blood lead levels between the two groups. So what is the difference in the true means of those two groups? And how can we go about estimating that? And how do we go about doing that? And what can we say precisely? And there's some difficulties there. We're going to learn all about that sort of thing. If we look at another example, let's say a study investigating a possible relationship between eggshell thickness and environmental contaminants in brown pelican eggs. This was from Anacapa Island in California. And it was suspected that higher levels of contaminants would result in thinner eggshells. Okay. We get this on DDT. They had some other measurements as well. They had PCBs measured and other things. But I'm just going to look at the DDT here. Shell thickness, DDT in parts per million for 65 brown pelican eggs. And we'd ask ourselves, if you're following along and thinking ahead, you might think, well, how did they get those 65 brown pelican eggs? And how did they arrive at that sample? And are there any problems associated with that methodology? Things we'll talk about later. So big picture wise, it's good you're thinking that. I'm proud of you. But we'll talk about that later. Now, here, we're exploring this relationship. Is there a relationship? Does there a relationship between DDT and shell thickness? And I'd say visually, it looks like there is one. It looks like this sort of cloud is decreasing a little bit here, right? I'd say it does look like that. There does seem to be this decreasing trend. But our statistical inference techniques will allow us to look at that a little bit more formally and say, does that data give us strong evidence that there's a real relationship? That we ask ourselves, like, what are the chances of seeing some sort of trend like this if the reality is there is no trend? And we're going to go through and learn how to do that sort of thing using something we call simple linear regression. And we'll talk about that towards the end of the course. And simple linear regression has one variable related to this. Multiple regression, very important thing in the world of statistics, but have more variables. So maybe we have DDT and PCB and use those to try to say something about shell thickness. And we might build statistical models to help us use this relationship, let's say, to predict. Sometimes we want to do prediction. I'd say not really as often as answering big picture questions like that, seeing if we have strong evidence of a relationship. Sometimes we want to use these models for prediction. But more important for us, I would say, is just the notion that we are exploring and investigating whether we have strong evidence of real relationships. We use statistical inference methodology to do that, to help us get evidence towards informing us about the true underlying reality. I think that's a pretty important thing. So more on this as we go.